Good afternoon, everyone. My name is Bill Kindle, and I'm going to be presenting to you this afternoon at VMware Code 2020, testing ESXi infrastructure with Pester using PowerShell and PowerCLI. I'm a cybersecurity engineer, former sysadmin of 15 plus years, and recent vExpert 2020. I'm a blogger, author, editor. I've done some work for the PowerShell conference book, volume 2 and 3, and I occasionally write for adamtheautomator.com. I'm really big into model trains, both large scale and small scale. And I'm a husband to a loving wife and 2 tiny humans. And just to show you how much I'm into trains, there's 2 little kids in this picture. This is my son and I in the cab of the famous steam locomotive known as the Nickel Plate Road, number 765. It's a Berkshire class S2 steam locomotive built by the Lima Locomotive Works well over 76 years ago. This engine is owned and operated by the Fort Wayne, Indiana Historical Society. And if you ever get a chance to see it in person, it's an impressive machine and quite a thing of beauty. And as you can tell, my son and I both are really enjoying ourselves there. Let's go ahead and go over some of the prerequisites that you're going to need to follow along with this demo. You're going to need to have access to an ESXi host. You're going to need at least PowerShell 5.1 or 7.0. You'll need to have some basic PowerShell and PowerCLI skills. And most importantly, you're going to need to have a willingness to learn and experiment. You don't have to follow along if you don't have any of these, but there will be code examples available in my GitHub repository, and there will be a link to that at the end of this presentation. So let's talk about a little bit about why testing your infrastructure is important. Well, first and foremost, testing your infrastructure reduces human error. Humans make mistakes. Testing helps discover these mistakes and enables us to mitigate them in the future. Mistakes can cost money and time. Repeating the same mistakes over and over is not acceptable in today's IT landscape. So testing for those past mistakes helps reduce troubleshooting overhead by eliminating known possibilities of past mistakes. And most importantly, doing the right thing because it's the right thing to do. Testing is the right thing to do. So you're probably wondering how you can test your ESXi infrastructure. Well, we're going to do so by using built-in Windows PowerShell modules called Pester with PowerCLI. So just what is Pester? Well, Pester is a ubiquitous testing framework for PowerShell. It's a domain-specific language, which means it usually has pretty easy to learn syntax. Great thing is it's built into every version of Windows PowerShell starting with, I believe, 4.0 and up. And it's not just for testing code. So what does Pester do for you? Well, you can test your PowerShell and PowerCLI code, making sure that your code only does what it's supposed to do and has the expected results. Going back to Pester being a ubiquitous testing framework, that's originally what it was built for. But you can also test and validate your physical or virtual IT infrastructure to make sure it's within acceptable parameters. So here's how you can get Pester. There's a couple of different ways you can do it. You can download and save the module directly from the PowerShell gallery using the code that I'm showing here on the screen. You can install the module directly on your system from the PowerShell gallery by using just the install module commandlet, or you can update the built-in module that's in PowerShell 5.1 to whatever the latest version is. I forgot to put it in here because the built-in version obviously is going to be an older version. It's not going to be the latest 5.0 release of Pester. You're probably going to have something at 3.0 or 4.0 more than likely. But if you use the -allow clobber parameter, you can install those versions side by side and call them individually if you want to. But by default, it'll use whatever the latest version of that module is. So let's dive right into some basic Pester syntax and structure. First, let's talk about the describe block. A describe block you can think of as a top-level grouping of tests. Think of them in as like a domain-specific context. So some examples would be You're testing network configuration parameters, you're testing host configuration parameters, or you're testing service configuration parameters. You know, it's kind of an arbitrary name, just, you know, something that makes sense to you. But all in all, it is basically, you know, a top level description of your test that you're getting ready to run. Next is the context block. So this is the context or scope of your testing that you're going to do. It's like a specific grouping of tests. So for example, you know, you're testing networking, you know, well, what part of networking are you testing? Are you testing the TCP IP stack? Are you testing like the host status? Or are you testing service status? Going on to assertion blocks, you run a test and you assert your expected value. So you're looking for something to be in that expected state. So your test will be in terms such as, you know, whatever my test is that I'm doing, followed by the PowerShell or PowerCLI code that's going to return a simple value that I can use to test against to be true or false. And that's the basis of our testing. You know, you just want to get your code to give you a simple value that you can say, okay, I'm using comparison operators to basically determine if that value is true or false. You'll see why that's important here in just a minute. And tags. I know in the VMware world that tags are are used quite heavily, especially with all the professionals that I know. They make heavy use of tags, and Pester supports tags. So when you're running your test, you can actually call individual tags to run individual subsets of tests. The reason for this is that you don't have to run around and call different scripts for your test. You can keep all of your tests in a single PowerShell script. And you know, it makes troubleshooting a lot easier, because then, you know, well, when I need to test something, I just have to call one script. But then you can use the tags to say, okay, well, I want to run this particular subset of tests. Here's an example of the syntax below. You could use invoke pester followed by the script parameter, the script name, and I give it a tag of network. So I can have all kinds of tests built into that script, but it's only going to run the ones that are tagged with the network tag. Another thing I want to point out here too is that notice the script name is, you know, I call it ESXi services.tests.ps1. The reason for that is that Pester tests are all just PowerShell scripts. When you use the invoke pester commandlet, it will scan every script that's in a directory until it finds one with the extension tests.ps1. So you'll see why that's important here in just a few minutes again. So here's what an example Pester test looks like. You'll see here that I've got describe blocks, context blocks, and a couple of assertion blocks. And that's pretty much the extent of most of the infrastructure testing that you would do would look like. You could just put in just simple PowerShell or PowerCLI code to run, say, you know, we want to get the member types for service in the first assertion block here. We'll run get service name bits, you know, something real generic. Well, down below, I will use service.status, and I want to make sure that that status should be exactly running. Well, that status member type, property member type, will just return a single value, whether it'll say running, stopped, paused, it'll say something. And Pester's syntax, you know, should be exactly, it's looking to make sure that that actual string equals running. So if bits was running on that system, this test would show up as a pass. The second assertion block here basically does the reverse. So if bits is already running, well, running doesn't exactly meet stopped, so that test would fail. And we'll show a live demo of kind of how that works here in just a moment. But this is the basic outline of what a Pester test could look like. So what is needed to run a Pester test, you might ask? Well, as I mentioned earlier, this module is already built into Windows PowerShell version 5.1, and I believe that version is at version 4. But if you go out to the PowerShell gallery, you'll be able to obtain the latest version plus older versions if you so desire. I want to say that the latest version is like 5.0.3, if I'm not mistaken, but it's a 5.0 release. I do know that for a fact. You'll need to have at least Windows 10 or Windows Server 2016 or 2019. Again, the module would already be built into those, so you don't have to download anything to get started. And it does work under PowerShell 7 too. There's some little bit of trickery that goes in behind the scenes on that, where I believe it's still calling the old Windows module through some of the more advanced, some of the advancements that have been made recently in PowerShell 7. And as I already mentioned, Pester is going to look in whatever directory you execute that invoke Pester command in, and it's going to look for any file, PowerShell script that ends with the extension test.ps1. So in theory, you could have multiple tests in different files if you so choose, and Pester will go through and run each one of those just by default. But best practice, in my opinion, is to just keep all your tests in one file and make use of the tags. So here's how we can go about running a Pester test. The version 4 way, you'll see that it uses invoke Pester with the script parameter followed by the script and the tag. That way it will still work in 5.0, but you might get a message that'll say that it's been deprecated in favor of the example that I'm showing you below. It changed script to path, which makes sense, and it changed the output to detailed. You have to specify in version 5 the output level that you want, because in the old days in 4.0, say you had a lot of tests and you just ran it, well, there's a potential there for your screen to scroll a little bit through all those tests and just kind of clutter up things. So in version 5, it gives you the output option, so you can actually just say, okay, just run my test. I don't need to see the on-screen output. Just tell me how many passed, how many failed. And then if you have failures, then you can run it again with the detail option and some additional parameters to see exactly which part of it failed. You can also execute the Pester scripts by themselves without any additional command. It does limit a little bit of the output that you get, but having a script that ends in tests.ps1 automatically invokes Pester on Windows machines. So the moment you all have been waiting for, let's go ahead and jump right into a real-world demonstration testing some infrastructure with Pester. So in the example that I'm going to show you, it's been recorded because I don't trust the demo gods. We're going to just do a real simple baseline checklist for a new deployment. What I'm going to look for, I'm going to look and see if the NTP daemon policy is set to on, that the NTP daemon is running, and that the NTP daemon is set to not required. You can use any checklist to build simple tests with Pester, especially with infrastructure tests. I've written some articles in the past on how to take tests or take checklists and turn them into tests. So we're going to do our validation testing using Pester. So as you can see in the code example here, I've started off with the describe block. I'm just going to call this ESXi 7-host deployment checklist testing. The context of the testing that I'm going to do is just called NTP tests. And you can see that I use the tag services. So in the if block, that's where I'm going to actually run the PowerShell code. So I'm going to set a variable followed by the PowerCLI code required to pull this information in. Now you might notice some other information missing here. I'm going to assume that you've already connected to your VI server, set your credentials, and that you're connected to your instance. And then below, using the member type properties of policy, I'm calling my variable and the policy property and making sure that it should be exactly on. I'm going to go ahead and add a couple more if blocks to this script. We're going to look for the daemon is running as false. Same thing, we're just setting some variables here, looking for that property key and making sure that it's equal to NTPD, and that its running property is set to false, and that the daemon required is also set to false. I got these from a bare metal deployment, no custom configuration, ESXi 7 host. Is running 7.0 B, if I'm not mistaken. The exact build, a lot of numbers off the top of my head, I just don't remember at the moment. But anyways, you'll see that I've just added those two extra additional if blocks, and again, those code samples are in my GitHub repository. So you'll see we got Pester in action here. This is just a screenshot, and I'm going to go over these numbered bullet points here. So you'll see that the first one is just how I'm just calling the Pester script, and I'm saying output detailed. That's how I get all the colored output. Number two, you'll see that it's actually running the discovery of all the files that are in that directory. So that's where I said Pester is actually actively looking for Pester test with that file extension. We get down to 3, and 3 is actually where all the tests are running. So you'll see that the first one automatically errored out with a failure because the NTP daemon policy is not set to on. But you'll see that our other two tests, our NTP daemon running is false, and the NTP daemon required is also false. So those two showing up in green are passing test results. And you can't see it here. You can't see it here in the bottom of the screenshot because it looks like it got cut off. I had a 5th bullet point there, and it basically is just showing you like a recap of all the test results. So you'll see like the test time that it took to run, followed by a count on how many tests passed and how many failed. You can barely see it here, but this test that I ran, the screenshot for, ran in under 352 milliseconds. So infrastructure testing is super fast with Pester, especially if you got efficient code. So I've already explained what's going on in the previous slide. Just to kind of reiterate, the detailed parameter will show you everything that you saw on the last slide. So just remember, if you want to see all the pretty output, all the the varying colors, make sure you use the dash detailed parameter when you run Pester. Now this is the recorded demo from that last screenshot. You should be able to see everything in real time here. So again, I run Pester, the output detailed parameter, and that's how fast everything happens. So let's just run that again. Type the command out, hit enter, and the full gambit of tests have been run. You'll see again, it completed in 365 milliseconds. Okay, some of the takeaways that you'll want to remember from this quick demonstration is that Pester is not just for code testing. You can test any kind of infrastructure as long as PowerShell or PowerCLI can reach it. Pester can build a test for it. Your tests can be as simple or as complex as you want them to be. As you'll see in my previous examples, just building a simple test to show whether or not a service is running doesn't take a lot of code to build out. Pester is going to make use of your existing knowledge of PowerShell and PowerCLI too. So once again, once you get your mind wrapped around the basic of the DSL language it's using, you only have to remember just a little bit. Everything else is literally just PowerCLI and PowerShell code. Pester is going to enable you to test, like I said, all aspects of your infrastructure. Again, if PowerShell can reach it, Pester can test it. So you're probably wondering, what other ways can I learn more about Pester? Well, The inspiration for me when I first started getting into infrastructure testing with PowerShell and PowerCLI is I picked up on the Pester book. That book will go through on how to test not just code, but it also mentions on how to test some infrastructure. It was, a great source of inspiration for me. I own a copy of it. I suggest if you want to learn more about Pester, you go out and take a look at purchasing a copy for yourself. If you want to see more of a up close and personal example of Pester in use in the wild for something other than infrastructure or code testing, take a look at PS Cones. PS Cones actually uses Pester framework to basically teach you PowerShell interactively. So it runs tests on code exercises that you run through to validate that you made the correct changes. It's really novel use for it, and I strongly recommend you go out and get a copy of that if you want to see some of the Pester tests and what it can do, or just learning PowerShell. There's a couple articles, like I said, that I've wrote and read. If you go to the infrastructure testing using Pester article, I go into detail on how I built, a simple infrastructure test in a Windows environment. And that also led to me beginning to test some of the ESXi infrastructure I had at my previous employer. Again, you can go out to GitHub and you can look at Pester. All the source code's there and openly available, and there's lots of good documentation on their official website as well. Well, thanks again for sticking out with me this afternoon at VMware Code 2020. I hope that you learned a little bit during this presentation and maybe get some ideas on how you can use Pester with PowerCLI to test your infrastructure. And if you have any other questions for me, you can hit me up on Twitter at Bill Kindle. That's BILLKINDLE. You can also scan this QR code here too to get the code examples out on my GitHub